Hello. Nice to be here. Okay, yeah, we are from Boombit, and we're gonna talk a little bit about LTV calculation or ROI calculation. Yeah, a few words about us. I'm Michał. Hi. I'm CEO at Boombit and captain of BoomQuest. Uh, I'm in gaming industry for the past 10 years, maybe a little longer, working mostly in production, marketing, yeah, basically all around. And last years, I'm focusing on developing BoomQuest in Boombit. More on that in a moment.
Hi everyone, I'm Hubert. I'm data scientist or machine learning engineer. I'm Boombit. I have been in Boombit since 2020, but I have 10 plus experience in this area. Currently, I'm mainly focused on providing some interesting solutions for UA. And basically, I'm kind of guy who works in basement, and this is my first time as a speaker, so please be understanding.
Yeah, he's here to answer all the, those tough questions. Okay, a few words about Boombit. So we are a game publisher, developer from Gdańsk in Poland, one in the, I think, biggest in Poland. We work on the hyper casual, casual, and mid-core games. So whole portfolio, we are over 300 people plus. And about this BoomQuest, yeah, we have this team that is focused on developed solutions for growth of the mid-core or casual titles, and we work on the games such as Hunt Royale, Darts Club, Royal Merge, and a few more. We also work on the new games still. And yeah, to work on those games, we also try to develop some new solutions. One the area which we'll be talking about today is machine learning, but we also do some managerial accounting tools and monetization design and live app solution. More on that later on today at 4:45. My friend Michał gonna share you some data about monetization in Hunt Royale. A lot of data, a lot of numbers. So if you are into it, please join us at 4:45 here. But yeah, let's go here. I like to start from the basics. So yeah, some basic stuff for you at the beginning. I know I don't know I don't know you, so let's start from the basics. Then there will be some meat. But yeah. What we are talking about. So basically, you want to invest the money. You have some, and you buying ads to show to promote your game to some target audience. Then if you are lucky, you get some installs out of them. Then they start playing. Then they might be engaging. So they might be buying in-app subscription, maybe watching ads. And at the end, yeah, you hope you're going to get some return on investment. Yeah. And the problem is that it takes some time. It's basically the same investment paradigm. Whatever investment you're doing is the same. We can talk about week, months, years, months. So yeah, it's just about the game, about your business plan and what you want to achieve, when you want to get your money back. And the tricky part is like, how can I predict this? Where I gonna be after 180 days? So it's half of the year. I spent money today. Okay, where I gonna be after 180 days? So that's the challenge we were trying to find a solution. So if I invest $1 million in January on those UA, where I'm gonna be in July? I'm gonna be broke or rich? Kind of important question. Yeah, this is how we usually looking on the data. This is historic data without any prediction or anything like that. It's just the historic data from one of our campaigns. The spend here, yeah, it's from a finger. It's not re-spent. Everything else is real. Basically, how we do that, it's like ROI week 0. It means that we are looking on, we spend for 1 week, and on the week 0, so the next Monday, we see, okay, where we are. And we're using ROI instead of ROAS. I know that there will be some speeches later on about ROAS, but usually we're using ROI. There's the big difference here is like on ROI, on 0%, it means that you are break even. On ROAS, on 100% means that you are break even. So ROI, you will see this negative results, which I believe it's better when you're spending money. I mean, I would like to know if I spent 100,000, if I'm in ROI perspective, I will see minus 50%. It means that I'm at minus 50% still. On ROAS, I will see 50%, but it means the same. I'm still negative, but I believe it's help you make better decision. And we can see some trends. Like we start on minus 79 on this week 26, we were on minus 23 or something like that. So you can see something that you maybe will be able to guess. If you look on the week 0 results, you can somehow try to guess where you are going to be on week 26. So this is something how you start. Yeah, and 1% means that you plus 1,000, minus 6,000, results like that. And now if we jump a little bit later, same game, similar campaign, and we would like to guess based on what we know. So we start with minus 79. So looking on historic data, yeah, probably something minus 14, minus 23. It should be at the end, but not really. Yeah, we are on the plus. Then minus 80. Oh, it should be terrible if we look on the historic data, but not so bad. Then another campaign, and yeah, again, it's end on the plus. So a lot changed in between those weeks, like from weeks 3, 4, 8. We see that the performance changed, performance of player, stuff changed. And why it's so hard to guess?
Yeah, the question is why it's so hard to guess. And from our experience, there are a couple of crucial points we can point out here. The first thing is quite obvious. One, the market is on which we are operate is constantly changing. We have our competitors, ad networks, of course users who evaluates over time. We have a legal framework and etc. So generally, the best thing we can do is to adopt as we can and try to provide tools and solutions that could be able to adapt as quick as possible. Okay, the other thing is that the structure of our data is quite complex. We have different networks as a type of campaigns, and which of them could be described with different patterns of revenue increase over the time. We try to implement our solutions to our products, which are basically game as services. So we have a lot of updates on monthly basis. We have live ops, which also evaluate over time. So it is quite hard to guess in such a changing environment. Our revenue model is hybrid, which means we have a lot of significant part of revenue generated from in-app purchases. And generally, if we talk about games which are basically based on ad, it's quite simple to predict revenue. But if we have a significant part of revenue from in-app purchases, it adds another complexity and randomness to our data, which move us to another point, which are super spenders, sometimes called whales. Basically, we observe here some supercharged Pareto rule, because in a lot of cases we see that not more than 1% of our users can generate 50 to 60% of our revenue. And the last thing is that in our case, our expected break-even is 6 months plus, which makes even stronger all of above issues mentioned.
Yeah, and we played this guessing game, and it's just the tip of the iceberg, because if you're doing those campaigns, you have more platforms, Android, iOS, networks, campaign, geos. So yeah, if you were trying to guess it by your own, it's more than 1,000 guesses each week or even daily. So yeah, it's making all of that quite complicated. So that's another challenge. So like human can't analyze such amount of data and come up with reliable results. So we start with some easy automation. Basically, what we are showing here is our journey for the past year. So this is where we start. We work for first like 3 months on the first solution. But before that, a little bit about data levels. So there is user level data. You have this user, they came into your game, and they leave some trace mark data, and you can try to analyze them on the user level. Then you can move them to the campaign level, so you can group them from the campaigns, like, I don't know, UAC, Google UAC campaign in Italy, yeah? for some time, and you can look on them as that, aggregate this campaign level. You can aggregate them at network level, and you can put it like you can go through that as a country to look on the country level instead. And we start for the first solution we named ROI Predictor, and we really need something that we know that we can deliver quite fast, because it was summer. We need something from the fall, because basically that's the season for UA. And we start from this ROI Predictor. So we said, okay, let's just focus on network level, country level, and let's see what we can get from that.
Okay, so at the very beginning of our journey, we decided to try with something very simple and in accordance with rule, simple is beautiful. And basically, at the very beginning, we made some initial assumptions regarding the data. And the first thing is that we decided to look at the data in weekly aggregates. Two reasons why we look at this way. One thing is that generally we knew we need quite a significant number of installs per each cohort analyzed. So this is some statistical reason. And the second thing is that, to be honest, we work and look at the data on a daily basis in weekly cohorts. So that is consistent with how we work. So the first thing is that weekly aggregation. Another limitation we put at data is that what Michał said previously, that we make aggregates up to country level. So our tool won't be possible to make predictions at, for example, campaign level. And last thing is that we also expected to provide model that will be a tool that will be dynamic, which means we'll be able to consume and feed all the data, all actual data, revenue data we have for each cohort. So, for example, if you have cohort with 7 days of actual data, we are starting prediction from 8 days up to 180. If we have 14, we started with 15 days, etc. So that was our initial assumptions. Another thing is that our data on which we based is only revenue data, broke down by ad and in-app purchase revenue. You can find here the graph, which represents the outcome of our model, but maybe a couple more words how our model was prepared. Our goal was to find this functional representation of revenue increase in time. So our goal was not to predict exact revenue for each cohort, but rather try to find how revenue increased over time. And it is represented in this formula you can find here. So our model, which was basically quite simple regression, maybe not as basic as linear, but because there is some polynomial component. But basically, it's quite simple, and our predictions are made as shown in this formula. So our output of our model is called model multiplier, which represents increase of revenue for given a moment in time, and the next prediction is made as shown. So revenue from previous time steps multiplied by this output of model. And as you can see, dash line is predictions, straight is actual revenue data. And assuming that on this chart we have only one network, for example, Facebook United States, we are able to provide predictions for each cohort we observe. And basically we'll show some specific numbers in the following slide, but maybe a couple of words, what was our expectations regarding to accuracy of the model. And it was quite straightforward. We at the very beginning, we assumed that we'll be satisfied with no more than a mean error of day 90 forecast, no more than 10 or 50%. Of course, it differs. It depends on how many installs we have in each cohort, but that was the goal.
Yeah, and we start using this system in Darts Club and Hunt Royale last year, somewhere October, September, and those are those early predictions on the left. without the dynamic model. It is just what we get for the week 0, yeah, for this first Monday after finishing the week, the prediction. And if you look on that, basically, yeah, we were kind of surprised when we were looking on this data, because we need this data with half a year to check. Before that, we were working on historic data and see how it's going to work. But if you look on this comparison, yeah, it's like 8% here. We find out that, okay, close, very similar. There are some outliers like minus 5% on day 180 versus whatever, minus 14. But basically, it's harder to get any better here results if you're looking for half a year in future. So frankly, we are kind of surprised how it works. Again, that's other game, Darts Club. Wrong title on the top, but yeah, this is Darts Club. And yeah, we can see something similar, and we can look on that on the network level, like, I don't know, Google, this country, and taking under consideration that we have enough data points and enough of data, enough of installs. This is how those predictions looks. Um, however, yeah, they are they are quite good for us. And like I said, as it comes to accuracy, I don't believe that we will be able to deliver something better at this point. But there are some limitations about them in the moment. Um, the model is dynamic, so we just show you the first prediction. But in fact, what's happening each day, there is an update when you have the more real data. So it's getting more accurate and more accurate with every day. We increase spend around 35%, like in comparison quarter to quarter. And also it came up with the bigger revenue because we know a little bit better what we are doing now. And we also find out that it works quite good in different types of games. Okay, both games are hybrid, but at the end, Hunt Royale is like 80% of income. It's from the in-apps and subscription, when on the Darts Club, it's a little bit opposite, where 70% of revenue coming from ads. As it comes to limitation.
Okay, so this was positive ones, but there are also quite a lot of limitations of such approach. The first thing is that this approach works as long as we have quite stable UA, which means, for example, if we started buying in new ad network, it probably doesn't work from the very beginning. It's not applicable at campaign level. In some cases, it is problem, but generally, in our case, it was quite enough. The third point is quite interesting, because why 7 days? As Michał said, we start our predictions after 7 days of actual revenue data. And why 7 days? It was a direct result of our backtest, which we made before we start using this model. And our observations showed us that this approach requires these 7 days, because starting from, for example, from first day of performance, the expected error of predictions is quite high, a lot higher than 10 or 15%. The last thing is that this approach has quite long learning time, which means two things, to be honest. Not only the fact that any big change in game, any big update in game which impacts significantly RPU or revenue per user, and our model needs quite a lot of time to discount these changes in revenue pattern. But there is also the second side, that we basically work on some historical data, so we need a lot, quite significant observation window for each application we want to implement this approach.
Yeah, especially this 7 day is something coming with additional risk, because now if you're spending in the first week of the year, let's say from the 1st to 7th January, you make the first prediction of that time at 14th of January, because you need 7 days from the whole cohort for every day. So yeah. So this limitation, especially coming with some risk, because now you spend, I don't know, 100,000 in the first week of Jan, and you have the prediction after 1 week, so on 14 Jan, but you are still spending probably. So yeah, you most likely would like to know what you are doing all the time. And we decide, okay, let's try to search for solution on user level data. We just start using this model already for UA to have something, but let's see if we can came up with something better. So we switch from here to this user level. As it comes to user level data, maybe some explanation. So everyone who download the game, start playing it, left some trace, some mark, and this is what we call user level data. It might be some. This is very big simplification of what it might be, but there is some attribution data like install source, date of install, some stuff like that. Maybe country. Another retention cost per install. Then there are some general engagement data, number of daily session, time of session, daily engagement time. Then we have monetization data, RPU, total RPU, eCPM, ads, in-app conversion, number of ads watched, ads engagement, stuff like that. And there is custom data. So usually anything you want, the data that design department use or monetization department use to know better the game. So all the custom stuff there. And there, of course, there are different data sources. And first of all, you need to sort out the data stack you have to be able to connect these all data sources and look on them. Fortunately, when we start, it was already done in Boombit, so that's something for us. We're using as attribution partner apps Flyer, analytics platform is Firebase. Then worth to look also in the mediation platform, store data from mediation platform, especially worth to take out the ECPMs or for ads ECPMs, and yeah, all other ads data that might be interesting for you.
Okay, so what was our approach in this experiment? Well, the question is, why even bother? Of course, we wanted to increase our accuracy, which is always the case. The second thing is that we wanted to overcome all of these limitations, which which our simple model brings to us. And we made at the very beginning, of course, some initial assumptions. The first thing is that we wanted to have predictions just after 24 hours after installation. So that is quite ambitious. It looks quite, well, maybe impossible, but we wanted to dig into it and try and check if what we are able to provide. And the second assumption is that we, at this point, we also didn't want to dig into some very complex model. So we wanted to use some simple one, maybe not as regression, but something that we could be explainable and flexible. Okay, so what about the data we used? We used not only revenue data, but also a couple more categories. For example, the session data, progression data. But we didn't use all stuff we had, because we decided to use only this one for which we have 100% that are only user dependent, not, for example, design dependent. So as I mentioned, we have ad revenue, impressions, in-apps by type, sessions, progression, all of this per user. And the model we want to develop was kind of something similar to what you could find in banking. We decided to use some scoring system which will be targeted to high spenders or high value users. And the output of this model will be probability of being high spender. And having such model, we wanted to make some segmentations. We used gradient boosting trees to make these scoring models, and having this gradient boosting tree model, we use it to make segmentations. And for each segment, in the end, the predictions is segment based, and is quite simple blend of historical revenue per this segment adjusted to the current performance.
Yeah, and you might be wondering why those 24 hours, because Hubert mentioned It was because SCAD network. Yeah, we want to know, okay, what we can know about user, what we can send as a conversion through the SCAD network after 24 hours. And basically what we get is this segment. So yeah, this is the this machine learning approach, because in fact what we did is like, okay, what users who, for example, at the day 90 were worth $100 plus, what they have in common, and then they find out in this, within these events we pick up, what's the common trends for those users to happens to make them this high valuable user at the day 90. And we get those segments like, yeah, for example, no spenders, players who spend something, and yeah, players who spend a lot. And in fact, we have around, we finish with 10 segments per game. And geo, as it comes to geo, we use some brackets, we use some geos for the bigger markets, like, okay, this is only from America. In other cases, we just did the brackets of some countries connected. Yeah, and some findings there. What we learned, because we start using that, and yeah, what we find out, yeah, it's good, it works, but it works only as it comes to segmentation. The problem is, if you segment all those users and you put on those segments and you even do it quite well, those segments are always like from here to there, especially as it comes to the whales. It might be starting somewhere there. So if you guess the segments, you know, okay, this is valuable user, but it's hard to guess the user value, like exact user value on the day 90, day 180, or whatever day you're gonna pick. Then that's something that's happening. User level data is somehow limited already. We have a SCAD, we have a sandbox coming, and basically the current trend is to protect people privacy. So we should expect that user level data will be more limited in the future, access to it and usage. Yeah, and then what Hubert said, that 24 hours is kind of short time.
Yeah, there is a lot of randomness in such long observation window. So basically, well, as Michał said, segmentation works, but exact value just only after 24 hours is quite impossible.
Yeah, and it came out with high error rating results if we do that, if we will start doing the test for the day 90, and now the results were differs from 20 to 60%. So it's more like a guess at the end, but it's more connected to this segmentation and the whole approach that it's you can't guess the user exact value after 24 hours, and if you start combining all those users you tried to do so, it came with some error. So yeah, that's our next challenge. When this can help to overcome some limitation of this ROI model, but it came with new problems and what we can do. So we start looking for some solution that combine both. And this is what we are working on at the moment. So yeah, we switch to a campaign level. We go a little deeper than in ROI predictor, but we are not looking on the, we don't plan to look on the individual user. We want to look on the campaign. But we want to combine those approaches. So yeah, this is the hybrid model in which we use segmentation, but we do this segmentation at the moment on the campaign level. Basically, we want to get the best feature from both model. Again, we have the results already similar to ROI predictor as it comes to the different. For now, forecasting for the 90. It's also dynamic already, so we're doing updates every day. So first is 24 hours, no, maybe not 24 hours. It will be somewhere between 24 72 hours, but it's quite early. The first prediction is daily based, but then each day we do the update of prediction to make them more accurate for the future.
Yeah, we used some more sophisticated stack that not only simple regression on even gradient boosting. We are in Google conference, so we use Google TensorFlow plus Keras API, which is quite flexible and impressive, and it's very easy to make quick data experiments. And basically, our data structure is also quite complex here because we have quite panel data, which is kind of 3D data. We have not only variables or features per each cohort, but also we have a lot of time steps to track it, and so we needed something more sophisticated here.
Yeah, Hubert, you scored 5 Google points, so I get we get something better from cafeteria. Then
And another thing is that we also observed that point forecast or point prediction is not the best thing to do with such data. So we decided to move to Bayesian analysis, I believe. So we don't want to predict exact value, but rather distribution of values for each cohort, which could be quite flexible and give us not only point prediction, but also confidence intervals, which measures a risk of our prediction.
And this is where we are, what we are testing at the moment, but we're still working on the SCAD-driven prediction. I hope that the next time on the GamesCamp, I will be able to tell you a little bit more about it. However, if you're interested, please catch me somewhere there or Hubert, and we are happy to share what is our approach to that topic. Then we want to be a little bit universal and flexible. In Boombit, we have this opportunity to work with a lot of games. So the idea is to be able to basically on server side just plug in next games to the system. So this is also something we have in mind. We'll be working in this year. Yeah, so this is where we are with this new approach. Oh, what is doing here? That's our panel. Yeah, this is how our panel gonna look like. Still in testing. I just put it like some randoms campaigns from the past, on which we are experimenting at the moment. What's interesting here? This part, it's like this certainty about the prediction, because when we use this user level segmentation, we just give it also to our growth manager, UA people, and to make the decision, and they only see at the beginning on the previous model, they only see this, yeah, like, okay, where are we going to be on this day 180, which makes some problems, because for example, if the cohort is low, now you can see that like, okay, low is minus 78, high it's 1%, and ROI here is minus 44. So this shows basically that the cohort is a little too small yet to get better guesses, because if you have enough data, like here, it's more getting a lot more stable. So basically, if you see 3 greens here, it's you are probably good. And the most important feature, of course, we have dark mode finally. Yeah. Yeah, so year of working and we have a dark mode. So yeah. Some takeaways here. Very general one, but I think they are important still. So if you want to guess the future, you can to some extent. If you have enough of data, please start work on this data because you might find out a lot of interesting stuff there.
Yeah, another point is quite obvious, but always worth to mention. The input data is key, and garbage in, garbage out rule. So nothing unusual. But in our case, when we work with such a collection, such a variety of data sources, it is crucial to understand what each data source provides us.
Yeah, my majority of this time was really to understand the data, what data we would like to look at.
Quite typical data science project.
Yeah, and again, that's another topic for the whole presentation. But if you are interested, please try to catch us, and yeah, we can discuss that. Then yeah, better to work in the interdisciplinary team if you have the imagination that you have some data, so you put some data scientists to work for you. It might be not the best solution. You need the people also who understand business, UA, and do some solution for them. It's a little more complex. Then yeah, experiment. So work on the live data. Start doing that if you have some data, because it's very hard to do it when you do not know how and you don't have a data. So not a point. First do the game, do the app, then start doing that. Lean and agile. Yeah, in this case, we really like every 3-4 months we change the approach because we understand where we are. We are always trying to identify a minimal viable product, something that already gives some value for our managers that help us works, but then pivot all the time. If we will have the imagination like, okay, we want the system like that in 1 year, we will be still doing that, and it will be completely when then we will deliver and no one will be able to use that because market already shifts. So you need to work in sprints, and you need to be agile, and you need to react. And basically it's not the system you will just do once, it will be still the project. So you still need to update because market is changing all the time. Few words at the end. So yeah, so this is the tool. We want to have it kind of universal in terms of Boombit till the end of the year. Also for games that we work as a publisher. So we also work on the hybrid, some other topics that I hope we will came back someday. So model prediction, then we do some solution for user acquisition, and for monetization. More about that also, Michał, later on. And yeah, if you're looking for publisher, sorry, my friend Mac asked me to put it there. So if you're looking for publisher, you can contact Mac. I guess that he's quite famous person, so yeah, you will find him. Yeah, and if you want to connect, that's us. Not so famous as Mac. So yeah,
I also have a LinkedIn.
please connect with us. You can catch us somewhere there. Also today at the party, or yeah, use LinkedIn because you can try on my email, but it's I can't promise that I will answer on email. So and also I guess that at some point we'll be looking for some studios to work with, to have to be able to test our solutions or even to talk. So yeah, really, if you work on that, we like to share. And so yeah, please feel free to contact, even if you are not looking for a publisher.
Thank you.
Oh, the questions?
No idea.
No questions. Okay, so how do you predict ROI for iOS users? Yay! That's the best one.
The hardest.
Yeah, we're using multiplayer. We at the moment we're using multiplayer basically. So we know part of the users that we know, and we have some rules how we multiply those results. So it's kind of stupid approach, I know, but this is something fast. And in terms of ROI predictor, it works quite good, really. However, on this user level, not necessary. That's why we want to switch to SCAT. And on the SCAT, we also do not think that we'll be able to predict with such accuracy that on Android, but what we will be able to tell, at least that's what we think, those segments. And we will be doing some scoring system for those users.
Right, to be honest, it's not just multiplier. There are some extra logic, and we are based also on SCAT data. But generally, it's not quite sophisticated as it should be.
Yeah, but in ROI predictor, it still works. So that's something good. Then, what is exact approach to multiply? Okay, yeah.
Well, I believe the question is to our simple ROI predictor. Yeah. So basically, yeah, just plain numbers, basically on historical data. I don't know what to add.
How does it look on iOS? Okay, this is the same, I guess. Okay, how many user and payers do you need in one cohort? Okay, that's a good one. Hubert, that's for you.
Okay, this depends as usual, but our expectation is that to be quite sure that we could provide some useful predictions, we'll need minimum 100 installs. Okay, so how often do you train GPT model on daily basis? Well, not on daily, weekly, I believe. But we started to use it. we don't use this model as we want to move to hybrid one.
No, Boris, you won't get you don't get more dark mode. Use the one on your browser or whatever. Someone asked about the new game. It were there, like what the approach for the new game should be. Just launch the game, start doing user acquisition, start gathering some data. If it's gonna, the magic with that, if the game works, it works, and you will be able to gather this data. If the game won't work, the prediction won't help you.
Thank you, guys. I think that you'll be terrorized by everyone on the
Please terrorize us.
Yeah.